Outliers are going to be numbers that are those extreme values, ones that are really big or really, really small. But if you don't want to just have it be an opinion question, you want it to be kind of cut and dry, you know, no gray area when it's an outlier or when it's not. So they have one method that we're going to use in this class, it's using the quartiles. So we're going to have a formula for figuring out when something is considered an outlier and when it's not. So first thing we're going to do is, once we figure out the first and third quartiles, we're going to compute the interquartile range, just like we did previously. And then the step 3 is we're going to determine what are called fences. So fences are going to be kind of our cutoff points. If they're inside the fences, they're okay. If they're on the outside of the fences, then they are outliers. So these are the formulas for your fences. I'll give those to you. You don't have to memorize them. So those are your formulas for fences. So you can see here you need to know your first and third quartiles, you need to know your interquartile range. This 1.5 is always there, that's a constant. You don't have to figure out where the 1.5 is coming from, it's just part of the formula. Okay, so we say if the data value is less than the lower fence or greater than the upper fence, so on the outside of the fences, it is considered an outlier. And we're going to go through the example we just did with the extra 100 mile per hour car in there, and it's very obvious that the 100 should be an outlier. I think pretty much everybody would assume that it is. But we'll go through and show the actual work that we would do for each of those problems. So you can see kind of how to apply the formulas. Okay, so without the 15th car, that's when we just had those first 14. We had our Q1 was 28, our Q3 was 38, and our IQR was 10. So those we already calculated already. So we know our quartiles, we know our interquartile range, we found those previously. Now we just need to figure out what our fences are. So if you come up here to our formulas, up here is our lower fence and our upper fence. I'm just going to abbreviate our lower fence. Just rewrite the formula Q1 minus 1.5 times IQR. And just be careful because this one's a minus, the other one's a plus. So just be sure you don't just copy too fast that you miss something. Just make sure you're double checking what you're putting in here. So this is going to be 15, so this is going to be 13. And then if you do your upper fence, you've got Q3 plus 1.5 times your IQR. This is 38 plus 15, 53. Okay, so those are our fences, 13 and 53. If we look back at our data set, which is pretty high up, we've got 13 and 53. Here we go, 13 and 53. All of our data values fall between 13 and 53. We don't have anything less, sorry, we're right. That's not what I want to do, sorry. Okay, so here, all of our data values are between 15 and 33. We don't have anything that's less than 13. We don't have anything that's greater than 53. So we've got all of our data values fall in between these two numbers. So in that case, we're not going to have any outliers. So I'll say all numbers are between 13 and 53. So there are no outliers for that one. Now if you throw in the 15th car, there's going to be an outlier, but now our Q1 and our Q3 and our interquartile range have changed. I think our interquartile range was 11. 39 and 28. 39, 28. So again, I'm going to write out my formulas and I'm just going to plug in the numbers that I know. Q1. It's 28 minus 1.5 times 11. And that one I actually. Let's see. That one I get 11.5. Upper fence. Now I get 5.5. Okay, so as long as the numbers are between 11.5 and 55.5, they're okay. If we look back at my values, 11 and here. So all of these values are between 11.5 and 55.5, so these are all okay. The only one that's not is this extra 100 miles per hour car that's included. So for this one, we'll say the speed of 100 is larger than 55.5. So 100 is an outlier. Okay, good. Good. Great. Okay. Okay, so 100 is not between 11.5 and 55.5. It's too big, so we're going to consider that one to be an outlier. Like I said, that one is easy to see that 100 definitely is way too big. We'll have some more examples in 3.5 when we do box plots of things that maybe aren't as obvious that they're outliers or not. Okay, so the last thing we're going to talk about in this section, right? Yep, is the percentile. Like I said, we're not going to have to actually calculate any of these things. Previous books that I used did have you calculate it, but it's just much easier just to interpret it because you're hardly ever going to actually calculate a percentile, but you do have to know what it means. So for this one, we'll say it's the case percentile, and they call it P sub K of a set of data is a value such that K% of the observations are less than or equal to that value. So if you're looking at the 32nd percentile, that means 32% of the data values are less than or equal to that. If you're looking at the 94th percentile, that means 94% of the data values are less than or equal to you. So these come in handy a lot. The time I use them the most is when I take my kids into their doctor's appointments and they tell me how big they are, and I don't know what that means because I don't know how much a 2-year-old boy should weigh. But they tell me what the percentile is, so I know since PJ's in the 72nd percentile that he is heavier than 72% of the 2-year-old boys. So that kind of puts a little more perspective into it than just knowing that he weighs 28 pounds. And they do that. So what it's doing, basically, they have a little picture right here. With quartiles, we saw they broke it up into 4 different regions. That's why it was quartiles. In this case, since they say percentiles, they're breaking it up into 100 different regions. So we've got 99 numbers all together, and you've got spaces right here. If they wrote out the whole thing, there would be 100 of them. So it's breaking it up into 100 groups, basically. So if you look here at the first one, your first percentile, that means you're greater than or equal to 1% of the population. Second percentile, you're greater than or equal to 2%. So if you're here at the second percentile, you've got 2% that are less than you. That means you've got the rest, everybody else, you've got 98% of the people who are going to be greater than you. So since PJ's in the 72nd percentile, that means that 28% of the babies his age are heavier than him. So same thing over here on the 99th percentile,
99% of the data values are less than you, and then only 1% are going to be greater than you. So that's what a percentile represents. And then this down here is going to be what the homework's going to look like, where you actually just have to go through and interpret it. So they've got the GRE, that's a test you have to take to get into a lot of graduate schools.